Welcome to the first in a series of deep dive videos on vSphere with Tanzu, a major feature that just shipped in vSphere 7 Update 1. My name is Ben Corrie, I'm an engineer on the project, and I really want to show off what it is that we've done with this product, taking you from absolutely nothing all the way through understanding the prerequisites, standing up a vSphere cluster, configuring it, enabling it for workload management, deploying a load balancer, and then ultimately our goal is to be able to stand up upstream Kubernetes clusters directly to vSphere and then demonstrate the integrations that vSphere brings to Kubernetes that ultimately supports the delegation model that is the whole basis of this product. The whole point of it is that it should allow vSphere admins to delegate resource to Kubernetes cluster admins and then have the Kubernetes cluster admins be able to delegate Kubernetes resource to developers. So we're going to go through this in a lot of detail. As I said, this is the first video. Now, this is not the place to start if you just want to learn about what is the value of vSphere with Tanzu. This video really is going to be focused on how does a vSphere admin get to the point where it's enabled. So if you want to learn about the point at which you can start deploying Kubernetes and start playing with it, either go to another video of mine, which I'll provide a link to, or there's plenty of resources already out there, and I'll just show you some of those resources. William Lamb, of course, if you use vSphere, you'll be aware of William's blog. He spent a lot of time creating a Power CLI script so that you can stand up vSphere with Tanzu in an automated fashion. So I highly recommend getting a hold of that and playing with that if you want to just kind of fast forward to the point where you can start playing with upstream Kubernetes. Of course, I'll be referring to the VMware documentation quite a bit throughout this presentation, so I'm going to have that open in the background. It's very, very comprehensive on exactly all the things you can do with it. Our sales engineers have produced a quick start guide, extremely helpful guide that takes you through all of the networking prerequisites that I'm going to show you. It's a very, very useful reference, so you can download that PDF and you can see the URL here. I'll post all these URLs in the description of the video. And also I want to call out Cormac Hogan. Cormac has a blog, and he has not only created really great blog content on some of this stuff, but also some shorter videos as well, kind of just giving you sort of a quick perspective on how to do some of this stuff. Now, I'm not attempting to duplicate that because really what I want to do here is go in depth on what you do, and really you're going to see me do this in real time. If things go wrong, I'll own up to it and we'll fix it together. I kind of like seeing people just kind of work through things like this, so that's why I wanted to make this sort of a very real-time interactive experience. The first thing I'm going to do is talk about my environment. Now, my environment is a home lab. It's nothing particularly fancy, but what's really important to understand about my environment more than anything is the networking setup that I have. Given that vSphere with Tanzu is specifically designed to work with just standard vSphere networking as opposed to NSXT, everyone can bring their own networks, and everyone's networks are different. And so in understanding whether your network is correctly configured or meets the required prerequisites to work with vSphere with Tanzu, I'm going to spend some time on explaining why my setup is the way that it is, and but also explaining how to validate that things are correctly configured as we go through. Because honestly, when you have lots of different types of networking and lots of different kinds of setups, the validation steps I think are some of the most useful. So let's talk about my setup. So I have 4 ESX hosts. These are physical hosts in a cluster, in a data center, in my vCenter. Now these physical hosts are connected to a switch, and the switch is connected to a Wi-Fi router. Now I am currently connected to my Wi-Fi router, which is called HomeLab 1. And if we look, I've got a list of all the IPs here, which explains how it all fits together. So my physical hosts, everything is in the 192.168.1 range, at least from a management perspective, all of these bits and pieces here. So my gateway and my DNS that the router's providing is at number 1. 2 to 9 I've set for DHCP, so that if I log in through Wi-Fi, it's going to give me a DHCP address. Now the physical switch that my ESX hosts are connected to is a managed switch. It's not a professional managed switch. It's more of a sort of semi-professional one. It doesn't allow you to configure. It does have VLANs, but it doesn't allow you to configure any routing between VLANs. So I'm going to talk about how we're going to set up routing as part of this video. But the physical switch has an IP address on that network. And we're going to set up gateways for 2 other VLANs, and I'm going to explain why we're going to do that a little bit later on. The physical hosts are 155 to 159. My VM kernel NICs have their own IP addresses for. These are the VM kernel NIC IP addresses down here, the 162 and the 166. So yeah, my physical hosts are here. Then I have a separate piece of hardware running vCenter. It's also running a FreeNAS server, which is exporting iSCSI as a different kind of shared storage. So vCenter is at 160. You'll see 160 is my IP address up here. FreeNAS is at 161. As I mentioned, the VM kernel NICs have their own IP addresses also on this network. And then we're going to be creating, from 170 onwards, we're going to be assigning IP addresses to our vSphere with Tanzu assets. Now, if you see WCP anywhere, it stands for Workload Control Plane. That was an early abbreviation we used on the project, and so it's hard to get away from, but you'll see that around. But it basically means vSphere with Tanzu. So this I'm going to call my management network. It's the network on which, as a vSphere admin, I can access all of my physical infrastructure and some virtual infrastructure as well. Now you'll see that I have 2 other networks here, a .10 and a .20. Now these are VLANs that I've set up in my managed switch, and they both have quite specific purposes. So the workload network is going to be a network onto which all of the vSphere with Tanzu assets are going to be deployed. Now, primarily, that's going to be the Kubernetes nodes. Right, so when we create a Kubernetes cluster, the Kubernetes nodes themselves are going to need to get IP addresses. They will get IP addresses on this network. And there's a few other bits and pieces on here that you'll see. We're going to deploy HA proxy onto that network too. But primarily, that network exists as a sort of an isolated sandbox for specific workload. So, for example, if one team deploys a Kubernetes cluster to vSphere, they might have a particular subnet that all their workload assets go into, which is isolated from another team's assets that are going to go into a different subnet, and again, are completely isolated from everything else. So the workload network cannot be accessed from the management network and cannot be accessed from the front-end network. There's nothing that routes to it. The only way that you can get to the workload network is by being on a virtual machine that has a NIC in the workload network. Now you'll see that when we deploy the supervisor cluster, it will have one NIC in the management network and a second NIC in the workload network, so that it can deploy stuff into this. Now the front-end network, which is the .20, is what we call the front-end network, and I put it in inverted commas because that might mean different things to different people. Fundamentally, though, it's a client network. It's a network that you would expect a Kubernetes admin or a developer to access the resources that are going to be set up by the vSphere admin. Now, this is also the network on which all of the load-balanced IPs are allocated on. You see here VIPs is virtual IPs. So HA proxy is going to create IP addresses in this range right here and you'll be able to access those IPs from this front-end network. Let's talk about routing. So the workload network needs to route to the front-end network. Now, the reason it needs to do that is because when we set up Kubernetes nodes on the workload network, and they talk to the Kubernetes control plane, they're going to talk to a load-balanced IP for the Kubernetes control plane, which is on the front-end network. So the workload network needs to be able to route to the front-end network in order to be able to access those load-balanced IPs. Now, in my setup, I've got the front-end network to route to the management network so that it can access the DNS server and so that it can access the internet. Now, you can configure that routing however you wish. This is just really the simplest way for me to do it. And as you'll see, when we set up our gateways, I'm going to set up a firewall so that even though front-end can route to management, it won't be able to access any of the physical infrastructure. Anyway, I'll go into detail about how to do that. As I mentioned, my managed switch can't do routing by itself because it's not fancy enough. So I'm going to create some Linux gateways in this cluster, and I'll show you how to do that so that we can configure our routing using VMs. So this is the setup that I already have, and to some extent the setup that we're aiming for. I hope that's clear. It should become more clear as we go. Oh, let's look at the storage that I have set up. If we go to here, you'll see my data center has a vSAN data store. This is physical vSAN. I've got nearly 4 terabytes of storage, and I've got that FreeNAS server that appears as iSCSI. And I use the iSCSI server for deploying content libraries to just anything that I want to make available to just any host is great to put on iSCSI. So the next step is to, let's have a quick look at networking, and I'll show you my VLAN setup. So I have a distributed switch. If we go to the configure tab and the topology, you can see how this is set up. I actually have 2 uplinks, the main switch, which is uplink 1, and a backup switch, which is uplink 2. Now, I don't need the backup switch. This is only a home lab, but I just put it in there just for fun. But basically, this switch is the main switch that all the ESX hosts are connecting to. And you'll see here, so we have a management network, which is VM kernel 0, which you'd expect. I'll just skip over these VLAN networks, and I'll come back to those. A VM network, which is standard. We've got a vMotion network here, which is VM kernel NIC 1, and a vSAN network, which is VM kernel NIC 2. So, what about these VLANs? Well, the way my switch is configured is that VLAN 1 is the default. So anything that comes in that's not tagged is tagged VLAN 1. And then I've set up these networks, these port groups. You'll see if I go to edit settings and click on VLAN, these port groups will tag the traffic with a specific VLAN ID. So this is tagging it with 10, this one is tagging it with 20, and the fact that that traffic is then tagged means that it'll be on that VLAN as it goes through the switch. Now, why am I using VLANs? Well, one of the prerequisites, and this is quite an important prerequisite of the bring your own networking, is there needs to be L2 isolation between these networks. So the management network and the workload network need to be L2 isolated. The workload network and the front-end network ideally also need to be L2 isolated. And this is partly because if you just use subnets and you don't have L2 isolation, the VMs can get confused about which MAC addresses correspond to which IP addresses. And that can manifest in some slightly odd behavior that's difficult to diagnose. So if in doubt, and most of our customers use VLANs as a matter of course, isolate these networks with VLANs, and that's how I've configured that. One more note is that my front-end network is accessible through a different Wi-Fi router that I put on that front-end network, because as I mentioned, given that I have isolation here, I can't route to my front-end network. Let's go back to here. I can't route to my front-end network from the management network because, again, it's isolated. So if I want to access to the front-end network, I'll click on that router and we'll do it that way. And what's nice about that is it kind of also forces a separation between what the vSphere admin can see and do and what the Kubernetes cluster admin and the developer can see and do. Okay, that's enough about my setup. It's a fairly standard setup, and we're going to move forward and start to set some things up. Okay, so the first task we're going to do is to set up our gateways, set up our routing, and then set up some client VMs to make sure that everything works as we expect it to. So the very first thing I'm going to do is create a Photon Linux VM that we can use as just a little test client to make sure that just our basic networking works correctly. And we can test things like vMotion and just some other things just to make sure that everything works. Now, setting up a Photon VM is actually remarkably easy. Now, I promised that I was going to start with nothing, and I really have started with nothing. So the very first thing I'm going to do is to create a content library to add that Photon ISO to before we create the VM. So a content library is a means of just deploying some useful stuff to vSphere that we can then access. So I'm going to create a content library called ISOs, and it's going to be a local content library. I'm going to put it on my iSCSI data store, and that's now created. So now I'm going to go into that and click import item and import a local file, and I want to import my Photon ISO. Okay, so give it, that's pretty quick to import. Okay, so while that's importing, let's go back to hosts and clusters. Okay, so let's create a new VM, new virtual machine. Create a new virtual machine. Now, of course, many of you will have scripted ways to do this. I'm using the UI so you can see what I'm doing. We'll call this Photon Client. It's going to go into my Bootstrap cluster because that's all I have. I'm going to put the storage for this VM on the vSAN data store. That's fine. And it's a Linux, VMware Photon Linux. Okay, now I'm going to get to configure it. Now, this is pretty much, I'm just going to take the standard settings. The one thing that I need to do is to specify that content library ISO file. There it is. Okay, so there's my Photon. Click on OK. Now, the thing that I always forget to do is to click this box, connect to power on. We want it to connect to power on. Make sure that it actually boots from that ISO. I think that's everything. We can choose to add things later if we want to. So let's click Finish. And there is our Photon Client VM. Let's power that on. Now I have DRS and vMotion enabled in this cluster, so it will just pick a host to deploy it to. You see it's picked 157. And we can click on here, hit Install. And as I said, it should install in about 30 seconds once you get an IP address. Okay, accept. That's fine. So I'm going to configure my network manually. Now, it doesn't really matter what IP address I give this at this point. If we go back to our list of IPs, I do want it to be on the management network, at least initially, because I want to be able to just validate and verify that I can at least get to the name server, that the name server is working. So let's deploy this to, let's deploy this to 13. Okay, 13 Photon Client VM. All right. So this is going to be 192.168.1.13. My gateway is 192.168.1.1, and my name server is 192.168.1.1. Okay, so okay that. Put a root password in. Start installation. Yeah. So this should take 30 seconds, and then we'll have a VM we can boot. Okay, as I predicted, 29 seconds. That's not bad. All right, so press any key to continue to boot. All right, so we want to leave this window open because we do want to get into the shell. Now, the first thing I do with Photon when the shell starts up is to allow SSH access as root. simply because it's much nicer typing into the Mac terminal than it is the backdoor terminal that you get with the vSphere UI. So I'll show you how to do that. Okay, here we go. So root, my password, excellent. Right, so the if you go to etc SSH, you'll see the SSHD configuration. So if we do vi SSHD config, and if we look for root, there it is, permit root login. So this is off by default. I'm going to say yes. Whoops. Okay. There we go. All right, now we need to restart SSHD to pick up that config. Right, now I should, from here, be able to log in. So if I do SSH root at 192.168.113, is it going to allow me to do that? It is not. Interesting. Okay, why is that wrong? So ifconfig is going to tell us, yeah, 192.168.1.13. That is definitely the correct IP. Now, one thing that we do want to do with these Photon VMs is the IP tables are set up as a whitelisting policy. So they're set up to drop everything unless it's specifically allowed. So let's just change that. So IP tables -p input accept, and then let's do that for output, and let's do it for forward. Okay, so IP tables -l will show you that it's now set to accept. So let's try pinging 192.168.113. I still can't ping it. Okay, that's interesting. Why is that? That is curious. What network am I on? I'm on HomeLab 1. I should absolutely be able to ping this. Let's try pinging one of my... Oh, interesting. Oh, you know what? I bet this is on the wrong network. Let's go to the... let's go to vCenter and double check that this is on a sane network. Edit settings. Oh, that'll be why. It's on the management network. Okay, it should be on the VM network. Okay, so if we switch it to the VM network, okay, now let's try to ping something else. There we go. Right, so I can ping one of my ESX hosts. Now from here, I should be able to ping that. I can, right? So now I should be able to get a shell. Yes. Great. So now I have a shell into that Photon client. So we can close this. All right. So I should be able to ping Google. Okay. So my name server, at least for the internet, is working, which means that I can reach 192.168.1.1, which is my name server and my DNS. So for now, that's good enough. Let's just make sure that we can vMotion this, make sure our vMotion capability is working. So if it's at 157, if I migrate this, change compute resource, and change it to 156, next, finish, and it should quite quickly, there we go, almost instantly it's on a different host. Great. So vMotion's working. Our basic networking is working. Now we can use this client to test other things as we go. But the next thing I want to do is to set up a gateway. Now the first gateway we're going to set up is the gateway. Let's look back at our list. The gateway that's going to route from the front-end network to the management network. So the gateway is going to need to have an IP address in the front-end network, and actually it'll be .1. It'll be consistent with the other gateways, and it'll need to have an IP address in the management network. And as you see, VLAN 20 gateway is going to be .12. So I'm going to create another Photon VM that we're going to configure to be our gateway. So I'll fast forward you through the process of creating that VM, and then I'll see you on the other side and we'll start configuring it. Okay, so the gateway VM is now created in exactly the same way as the Photon client VM we created a moment ago. What I haven't yet done is configured it to be a gateway, and that's what we're going to do right now. So the first thing I'm going to do is to get a shell into it. You'll see it's address 1.12. So if I do SSH 192.168.1.12, okay. So let's look at the interfaces. Currently, it has one interface on the management network with that 1.12 IP address. So we need to give it another interface on the front-end network, which is VLAN 20. And of course, it's going to have 20.1 as the IP address. So we're going to add a NIC to this VM. And one of the nice things about vSphere is that you can add and remove NICs while the VM is powered on. So there's a new NIC. You'll see the first NIC is on the VM network, which is by default VLAN 1. And the second NIC is going to be on the front-end network, which is VLAN 20. Okay, so now that we've done that, we're going to add a guest interface by typing ifconfig eth1. That's going to be the name of the interface. And 192.168.20.1 is the IP. And then up just tells it to bring it up. Okay, so there's our second interface on 20.1. Excellent. So what are we going to do now? Well, the next thing to do is to actually configure this to be a gateway because it doesn't know how to forward traffic right now. In fact, if we look at the IP tables, you'll see it's configured to, by default, drop everything except things that are explicitly configured. Now, the script that I'm going to use to do this is in GitHub, as is everything that I'm going to be doing over the next few videos. So just go to GitHub and you can follow along with me and copy things out of here. So I'm going to call this config.sh. Now, let's just run through quickly what this is doing. As I mentioned before, I'm just changing the default IP tables to accept everything, so a blacklisting policy. And then I'm adding some forwarding rules which will forward traffic from ETH1 to ETH0. Then the final rule I have here, I mentioned previously that I wanted to set up a firewall rule so that no front-end traffic can get to any of my vSphere physical infrastructure, which is on like 1.155 and up, basically. So this rule, this simple rule, ensures that nothing that comes in to an IP address above 1.128 can be forwarded to the management network, and it will drop those connections. So it's a pretty simple firewall rule. You can make it more elaborate if you wish, but that should do, and we can test that in a minute. Okay, so let's make this executable, and then let's run it, and then let's see what difference it's made. Okay, there are our rules. So now we should have a configured gateway. Now note that the rules that we've configured are ephemeral. If we restart this VM, it's going to have lost those rules, but it's going to be very easy to reconfigure if that were to happen. Okay, so let's test this. Now, the first thing I'm going to do is to make sure that if I go to the front-end network, I can actually ping it. Note that on my management network, if I try to ping it on its 20.1 address, I can't because the management network and the front-end network are isolated. So let's go to the front-end network, and at the very least to make sure that as a client on the front-end network, I can ping it. And there we go, I can. That's great. So test my gateway. I want to make sure that it forwards traffic and that it works as expected. Now, the simplest way to do that is using the existing Photon client VM that I created and to just modify it to be on that network, to be on the front-end network instead of on the management network. And that's actually remarkably simple. If we go to Edit Settings and just modify the network that it's on to VLAN 20, which is the front-end network. Now, we'll get into the shell here because now that it's on 20, we won't be able to get into a shell from my MacBook, but we can always get into a shell from the management console. So if I click in here, you see, okay, so the IP address now is wrong for that network, so we're going to reconfigure that. ETH0 is going to be 192.168.20.2, let's say. I don't think anything's using that. Netmask. Okay. And then I'm going to change the default gateway because currently the default gate will be set wrong. So that is, let me just remind myself what that is. That is root add default GW. Okay, so this is going to create the right gateway on that interface. Now, fingers crossed, I should be able to ping my gateway. I can ping my gateway. Now I should be able to ping the gateway on the management network. So it should be forwarding that ping traffic. Yes, it does, which means that it should now also be able to get to DNS. So if I ping google.com, excellent. So forwarding is working, DNS is working, everything's working. Now let's make sure that that firewall is working that I configured. Can I ping one of my ESX hosts, 1.155? I cannot. That's great. So the front-end network is not able to access any of that physical infrastructure on the management network. Excellent. So I've set up my first gateway and I've set it up on the front-end network. The next thing to do is to set up the second gateway, which is going to be on the workload network. And that gateway is going to route to that front-end network. That'll be the next task. Okay, so as you can see, I've configured my second gateway. It's all created, powered on, running. You'll see that it has the IP address 10.1, which is the IP address that everything deployed to the workload network will specify as its gateway. And you'll see it has a second network interface on the front-end network, which is where it's going to be forwarding traffic. And traffic that gets forwarded to the front-end network will go through the front-end network's gateway that we already created and will get forwarded on to the management network gateway. So let's test that. Here's our Photon client. Now I've already modified this in the same way as I did previously to be on the workload network. Now the only way to get onto this VM is through this backdoor. So what should we be able to do on this VM? Well, let's firstly look at the interface. Okay, so it has address 10.2 and it will have 10.1 configured as its gateway. So let's firstly ping 192.168.10.1. Can I ping my own gateway? Yes, I can. Okay, so now if I ping 20.1, is it going to be able to forward traffic to the front-end gateway? Yes, it can. So now can it see the management gateway? Yes, it can, which also means that it should be able to resolve. Yes, it can. Good. So the final thing I want to check is that the firewall is still good on this network, which it is. Because traffic is being routed through the previous gateway we set up that has the firewall on it, those same rules apply. So that's good. So we now have all of our routing infrastructure set up, and we can go ahead and we can start creating our compute infrastructure.